In the first two models, we built the roads, the secure checkpoints, and the communication pipes for our AI agents. But architecture means nothing if you can't control the cargo traveling through those pipes. And when dealing with AI, the cargo, the data, is inherently dangerous. To understand why, I want you to imagine your large language model as an unpredictable genius, and your fast API backend as an automated assembly line. The genius is brilliant. It can read a 50-page document and make incredible strategic decisions. But the genius is also a storyteller. If your assembly line asks the genius for a user's age, the genius might reply with the number 25, or it might reply with word 25, or it might reply with a JSON object saying the user is 25 and just had a birthday. To your Python code, only the integer 25 works. Any variation causes your entire factory to crash. To bridge this gap, we need two things: the universal contract and the enforcer. First, the contract. This is JSON Schema. JSON Schema is not a programming language. It's a universal language agnostic vocabulary for writing strict legal clauses about data. It defines the exact shape of the data the genius is allowed to hand to your assembly line. There are 4 clauses you need to master. First, type. It defines the physical material. Is the data a string, an integer, or a nested object? Second, properties. These are the specific labeled boxes the genius must fill out. For example, first name and age. Third, required fields. These are the absolute non-negotiables. If the genius forgets to include a required field, the entire contract is void. Fourth, any of. This is the multiple choice clause. You tell the genius, this field can either be a string or a boolean, but absolutely nothing else. But here is the most critical concept for the AI agentic engineering. By default, JSON Schema allows extra data. If you ask for a name and the LLM provides a name and its current mood, standard validation just accepts it. Large language models are notorious for being helpful and hallucinating extra keys that you didn't ask for. To fix this, we use a setting called additional properties false. This is the no improvisation clause. Setting this creates a rigid, impenetrable boundary. If it forces the LLM to color strictly inside the lines, preventing unexpected hallucinated data from poisoning your microservices down the line. So we have our contract, but writing raw JSON schema by hand is terrible. It's tedious and it's prone to errors. But we are building in Python. We use Pydantic. If JSON schema is the written contract, Pydantic is the ruthless enforcer, standing at the door of your backend. In Pydantic, you define Python classes using standard type hints. Pydantic automatically reads this and says, if the incoming data is the string 25, I will coerce it into integer 25. But if it's the string 25, I will throw a massive validation error and block it from entering the system. Pydantic doesn't check the data, it transforms it. It takes the raw messy JSON string output by the LLM and instantly parses it into a clean, predictable Python object. This brings us to the ultimate agentic superpower: function calling specifications. In the old days of AI, we had to write long system prompts, begging the model, please output your response in JSON. Please make sure the age is an integer. Please do not add extra fields. Then we just crossed our fingers and prayed. It listened. Pydantic and JSON Schema eliminate this hope-based engineering. Here is the exact pipeline. You write a Pydantic model defining the exact arguments LangGraph tool needs. Pydantic automatically translates itself into a pristine, deeply nested JSON schema. Then you pass that JSON schema directly into the OpenAI or Anthropic API via function calling. By doing this, you're hardwiring the LLM's brain. The model's internal architecture reads that additional properties false clause and it physically constrains its own generation. You're no longer hoping the unpredictable genius follow the rules. You're handing it an ironclad stencil. So master the pipeline and you have officially cured formatting hallucinations. Till now we talked about the unpredictable genius and the assembly line. We learned that to prevent AI hallucinations we need an ironclad contract JSON schema and a ruthless enforcer Pydantic. Now we are going to see the code that connects them. I am going to show you exactly how to build a Pydantic contract, export it as a JSON schema and hardwire it directly into an OpenAI function call. Let's jump into the code. We start by writing our contract in Python. We do this by inheriting from Pydantic's base model. Let's say our AI agent needs to read an email and extract a user's profile. Here is how we define the boundaries. Look at the field definitions. Notice how we are providing explicit descriptions. Because this class will eventually be read by an AI, these descriptions act as mini prompts. We are telling the LLM exactly what belongs in these boxes. And because we used Python type hints like int for age, Pydantic will instantly reject any text-based numbers. But here is the most important part of this file. Model_config is equal to extra forbid. Remember the no improvisation clause we talked about. This single line of Python is how Pydantic generates additional properties false. In the final JSON schema, this physically prevents the LLM from hallucinating extra fields. Now we have our contract. How do we hand it to the genius? We are going to take that Pydantic class, dynamically convert it to a JSON schema and inject it into our OpenAI API call using their tools parameter. Let's break down exactly what is happening in this function. Step 1. We call model_JSON_schema. Pydantic instantly writes the complex deeply nested JSON schema for us. No hand coding required. Step 2. We build our tool definition and we inject that generated schema directly into the parameters block. Step 3. We make the API call, but notice line 26. We are using tool choice. We are not asking the LLM to use this tool. We are forcing it. We are telling the API you are not allowed to respond with regular chat. You must fill out this exact form. Step 4. The enforcer. The enforcer steps in. When OpenAI returns the response, it's just a raw messy JSON string. We pass that string into user extraction.model validate JSON. Pydantic inspects it, verifies there are no extra fields, confirms the age is an integer and returns a pristine Python object that your fast API backend can safely save to a database. No more prompt engineering for formats. No more hoping the model listens. So define the Pydantic model, generate the schema, force the tool call, validate the output. Implement this exact pattern and your AI pipelines will never break from bad data again. Hope this is useful. See you in the next video.